In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James's Walker. So let's start. So in this question, we have to find the launch angle for which the range and the maximum height of a projectile is same. So this is what we call the range, the horizontal distance traveled by the projectile before landing, and this is the maximum height h max. Now in our previous videos we derived the formulas for the maximum height and the range, and if you haven't seen those videos, please first go and see those videos first. Okay, so h max, we derived this formula to be equals to v0 sine theta whole square divided by 2g, and this formula is valid only when the initial and the final positions of the projectile is same. And the range, we derived this formula to be v0 square sine 2 theta divided by g. Now we're going to equate these two things to find the theta, because it is given that range and maximum height are same. So let's equate these two things and find the launch angle theta. Okay, so we have this is v0 square sine square theta divided by 2g. This is h equals to r. So r, we have v0 square sine 2 theta divided by g. Now from here, this v0 square cancel, g and g will cancel. Now further we can write that sine 2 theta, this is equals to 2 sine theta cosine theta. We can use this formula, this trigonometric formula. So this would become and this sine square theta as it is divided by 2 is equals to 2 sine theta cosine theta. Now from here, this sine theta and this sine theta will cancel, right? And cosine theta I can take to the left side. So sine theta over cosine theta is tangent theta, and this 2 I can take to the right side, so it would become 4. Now from here, theta would be tangent inverse 4, and use your calculator to find this value, and it comes out to be as nearly 76.0 degrees. So this is the required answer. That is, if you throw the projectile at an angle 76 degrees, then the range and the maximum height attained by the projectile will be same. Let me represent on the figure also. This angle theta we have found out to be as 76 degrees. Now in this question, we are given that a projectile is fired from y equals to 0 with initial speed v0. So this is the projectile fired with initial velocity v0 at an angle theta. So this angle is theta, and this projectile lands on a different level, which is y equals to h. It lands here. Now we need to show that the time of flight for this projectile is given by this expression, and in this expression, this t0 is the time of flight for h equals to 0. When h becomes 0, the time of flight is t0. Basically, when h becomes 0, the projectile will land on the same level with which it was thrown. When h becomes 0, this would be the landing point for the projectile. Okay, and this h here, this h is the maximum height of the projectile. So this is the maximum height. This is what they are saying. This is h. Now first I'm going to find the time of flight for the projectile that lands on the same level, that is this level. Then what would be the time of flight? And for that we can use this equation, y equals to y0 plus v0 y times t plus 1 over 2 a y t square. Now here at this point y is 0, and here also y is 0. So y0 is also 0 and y is also 0. And this time it becomes t0, because when h is 0, the time of flight is t0. This is what is given in the equation. So we can replace, this is 0 equals to 0, and v0 y is v0 sine theta multiplied with t0 plus 1 over 2 ay is minus g, and this is t0 square. Now from here, the expression for t0 is 2 v0 sine theta over g. This is the time of flight for the projectile when it lands on the same level. But we have to find the expression for the time of flight when it reaches here at this point. For that, what we can do is, first let us find the time taken by the projectile to reach at this point. And for that we can use this equation. Vy is equals to v naught y plus ayt. Now at this point the vertical velocity becomes 0. So this Vy we can equate it to 0. And v naught y is v naught sine theta. So v naught sine theta minus this we can write as minus g, because ay is minus g. Now this time t is time taken by the projectile to move up at this point. So we can write this thing as t up. That is time taken by the projectile to reach at the maximum height. So from here t up, this comes out to be as v naught sine theta over g. Now let us find the time taken by the projectile to move from this point to this point. And for that we can use this equation. Y is equals to y naught plus v naught y times t minus 1 over 2 gt square. Now this is the final position. Now final position becomes h, and initial position here, this is a capital H. And v naught y is the velocity in the vertical direction at this point, which is 0. So this whole term is 0. And then this is minus 1 over 2 g, and this is the time of down, because the projectile here is coming down. So I'm just writing it as t down. Now from here the expression for t down comes out to be as under root 2 times h minus h divided by g. Now what would be the total time of flight from this point to this point? We have to add both these two terms, this one and this one. So this would be t will be equals to t up plus t down. We can write this way. And t up we have this thing. This is v naught sine theta divided by g, and t down we have this thing. So this is under root 2 h minus h divided by g. Now earlier we derived one formula, this one. This is v naught sine theta times 2 is t naught. So from here we can write one thing, that t naught over 2 is v naught sine theta divided by g. So this we can write it as t naught divided by 2. From here, if you compare these two things, we can write this way, t naught by 2. Now plus under root. Now do one thing, take h common from the numerator. So 2h I have taken common, and g I am writing it here. So this would become 1 minus h over capital H, right? And this capital H is the maximum height attained by the projectile, and we have derived one formula for h to be equals to v naught square sine square theta divided by 2g, right? So we can replace h here. And why we are doing this? Because we need to replace this g here, because in our expression there is no term of g here. We have t naught h capital H, but there is no the term for g. That is why we are all doing this. So that this g is cancelled out. Okay, so t naught over 2 plus under root 2 times over g. Now h we have this thing, so this is v naught square sine square theta divided by 2g, right? Now from here this 2 and 2 will cancel, and rest as it is, 1 minus h over capital H. Now what is this? V naught square sine square over this would become g square. Now if you compare this expression with this one, let me just copy it so that you can compare it easily, and I'm pasting it here. So v naught square sine square over, so we are basically squaring it and whole squaring. So this would become t naught square over 4, and this is v naught square sine square theta over g square. So we can replace this thing here, right? So this would become t naught over 2 as it is, plus under root, this is t naught over 2 whole square times 1 minus h over capital H, and this is equals to capital T. Now further, take t naught by 2 common. So t equals to t naught by 2 I am taking common. So this would become 1 plus under root This is also 1 times 1 minus h over h, and further t is equals to t naught over 2 multiplied with 1 plus under root 1 minus h over h. And this is the required expression that we need to prove. This one. Hence, proved. So in this question it says that most projectiles continually move further from the origin during their flight, which is true also, but this statement is not true when the launch angle is greater than 70.5 degrees. Let's take an example to understand this. So they have taken an example that launch angle is 75 degrees, which is greater than this value, and the initial speed v0 we have 10.01 meter per second, and we are given with this graph. Now in the A part we need to find the distance from the origin to the projectile at the start of the red portion. Now this red portion starts from here, so basically we have to calculate this distance. Let us call this as dA. This distance we have to find in the A part. Okay, now for that this x value we already have. At this point, x coordinate is 3.05. Now y coordinate we don't have, so we're going to find the y coordinate first, and for that we can use this equation. Y is equals to v0 sine theta multiplied with t minus 1 over 2 gt square. Now here this is the time at this point, but we don't have the value of time, so do one thing, first calculate the time. And for that use this equation, x equals to v0 cosine theta multiplied with t. So from here this t would be x over v0 cosine theta. X we have 3.05, v0 we have 10.1, cosine theta is 75. Now from here this t comes out to be as 1.17 seconds. Now put the value of t here. So y would be equals to v0 is 10.1, sine theta is 75, t is 1.17 seconds, minus 1 over 2, j is 9.81, and t square is 1.17 and its whole square. Now from here this value of y comes out to be as 4.70 meter. Now it's pretty simple. The distance dA, this would be under root x square plus y square. So x square we have 3.05 and its whole square, plus y square is 4.70 and its whole square. So this value comes out to be as 5.60 meter, and this is the answer for the A part. Let me write it here. This is 5.60 meter. Now next we have to find the distance from the origin to the end point of red portion. So the red portion ends here, so we have to calculate this distance, and let us call as dB. Now again we'll find the time when the projectile reaches here. For that you can use this equation. Just one change here, this 3.05 will become 4.75. So this is the B part. So t is 4.75 divided by 10.1 cosine 75 degree, which is equals to 1.82 seconds. So now put this value of t here to find the y value. This x value is 4.75, and for the y value put t in this equation. So y is equals to v0 sine theta multiplied with t. So v0 is 10.1, sine theta is 75, t is 1.82. Now minus 1 over 2 gt square. So 1 over 2, g is 9.81, t is 1.82 and its whole square. Now from here this value of y comes out to be as 1.51 meter. So this is 1.51. Now it's very easy. dB will be under root x square plus y square. X square is 4.75 and its square plus this y square is 1.51 and its whole square. Now from here this value comes out to be as 4.98 meter. So this dB is 4.98 meter. Now if you compare, this dA is greater than this value. So as it moves during its flight, the projectile is coming near to origin, and this is what the statement was saying, that if this angle is greater than 75 degrees, then the projectile will move near to the origin, which we can see here also. This is 5.60 meter, and here the distance becomes 4.98 meter. Okay, now next in the C part, we need to find the distance from the origin to the point where it just lands. So basically we have to calculate the range. This is what we have to find in the C part. So directly we can use the formula for the range to be equals to V0 square over G sine 2 theta. Put the values and get the answer. I'm just writing the answer because we have solved multiple problems like this. So I'm just writing the answer. This would be 5.20 meter. So this would be the answer for the C part.